everyone, especially to all our matatalino grade 10 viewers. Welcome to our virtual mathematics class. I am Sir Ron, your math mentor who will guide you in your journey in this exciting world of numbers. Are you ready for another episode of fun and learning? Before we start, make sure you have your pen, paper, and self-learning module.
Now, let us practice first our counting skills. On a sheet of paper, answer the following questions. From the counting numbers 1 to 20, number 1. How many are prime numbers? If your answer is 8, you are correct. Next question. How many are composite numbers? If your answer is 11, you are correct. Next question. What numbers are odd? If your answers are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19, excellent! You are right. Next question. What numbers are divisible by 3? If your answers are 3, 6, 9, 12, 15, and 18, good job! You're right. Next question. How many two-digit numbers are greater than 13? If your answer is 7, you are correct. Congratulations! Let me guide you on your next journey. Let us now consider a given situation. A small padlock treasure chest was found in an abandoned island. In order to open this chest containing precious jewels, a 4-letter password without repetition must be unlocked using the letters A, B, C, and D. If you are going to list down all the possible codes, how many codes will there be? How many codes were you able to write? If you have listed 24 codes, then you are correct. What strategy did you use to find the 24 possible codes? To illustrate how this can be solved, let us construct a tree diagram. First, let us list down all the possible choices in the beginning. So we have A, B, C, and D. On the second part, our choices will be decreased since if a letter is selected, it can no longer be used. If A is the first letter, then our next remaining choices are B, C, and D. If B is the first letter, then our next remaining choices are A, C, and D. If C is the first letter, then our next remaining choices are A, B, and D. If D is the first letter, then our remaining choices are A, B, and C. For the third part, our remaining choices are C and D, B and D, B and C. Next, in this part, our remaining choices are C and D, A and D, and A and C. Next we have B and D, A and D, A and B. Okay. Then we have B and C, A and C, A and B. Looking at previous letters, we only write the remaining letter. We have D, C, D, B, C, B. Next, we have D, C, D, A, C, A. Then, we have D, B, D, A, B, A. And finally, we have C, B, C, A, B, A. Following the diagram, we can now list down the possible codes. First is ABCD. Another code is ABDC, ACBD, ACDB. Following this pattern, we can now have the following codes. Altogether, we have 24 possible codes. Another solution to find the number of codes aside from tree diagram is by using the fundamental principle of counting. The fundamental principle of counting states that if one object can occur in P ways, a second object can occur in Q ways, and a third object can occur in R ways, and so on, then the sequence of things can occur in P times Q times R and so on ways. To do this, let us provide 4 blanks for the first part, second part, third part, and fourth. There are 4 possible letters that we can choose from in the first part. If a letter has been picked, it can no longer be used. Thus, there are 3 remaining choices in the second part, 2 letters remaining in the third, and 1 letter in the last. Multiplying the numbers, our answer will also be 24. The situation above specifically involves permutation. A permutation is an arrangement of things in a definite order or the ordered arrangement of distinguishable objects without repetitions among the objects. Given the letters A, B, C, and D, an alternative way to determine the total number of arrangement or permutation is to use the formula n factorial equals n times quantity n minus 1 times quantity n minus 2 times quantity n minus 3 and so on times 2 times 1. Since there are only 4 letters to be arranged, that means n is equal to 4. n factorial, n equals 4. So we have 4 factorial. 4 factorial equals 4 times 3 times 2 times 1. Multiplying the numbers, the answer will be 24. There are 24 possible codes. Congratulations! We have solved the given situation in 3 different approaches. Let us have some more examples. Example number 1. If you have 3 different t-shirts, 2 pairs of shorts, and 2 pairs of shoes, how many outfits composed of a t-shirt, a pair of shorts, and a pair of shoes would you have? Let us use a tree diagram to illustrate our solution. Let T sub 1, T sub 2, and T sub 3 represent the t-shirts. H sub 1, H sub 2 represent the shorts, and S sub 1, S sub 2 represent the pair of shoes. First, let us list down all the possible choices in the beginning. So we have T sub 1, T sub 2, and T sub 3. On the second part, each shirt can be partnered with H sub 1 and H sub 2. On the third part, each can be further partnered with S sub 1 and S sub 2. Following the diagram, we can now list down the possible outfits. First is T sub 1, H sub 1, S sub 1. Second is T sub 1, H sub 1, and S sub 2. Third, T sub 1, H sub 2, S sub 1. Following this pattern, we now have the following outfits. Altogether, we have 12 possible outfits. Congratulations! Another way to solve the problem is through the fundamental principle of counting. Provide 3 blanks for the t-shirt, pair of shorts, and pair of shoes. There are 3 choices for t-shirt, 2 choices for shorts, and 2 choices for shoes. By fundamental principle of counting, we have 3 times 2 times 2 is equal to 12. There are 12 different outfits. I do hope that our first example is clear to you. Let's now focus on another situation involving permutation. Example number 2. Which of the following situations illustrate permutation? A. Arranging potted ornamental plants in a row. B. Selecting 4 kings in a standard deck of cards. C. Listing the possible passwords of a smartphone. If your answers are A and C, you are correct. Situations A and C show permutation. Order or arrangement is important in these cases. Situation B does not show permutation since the task is only to select or choose 4 kings. Order, whatever it is, does not matter. Example number 3. Maurice, Joshua, and Ben will arrange themselves in a row for picture taking. How many different arrangements in a row will be formed by them? Aside from 3 diagram, another way to find the number of arrangements is through listing method. The whole set must be enclosed with braces and each element must be separated by a comma. If we are going to list down all the possible arrangements, we'll have Maurice, Joshua, Ben, Maurice, Ben, Joshua, Ben, Maurice, Joshua, Ben, Joshua, Maurice, Joshua, Ben, Maurice, and Joshua, Maurice, Ben. Another solution to answer the situation is by applying the concept of permutation. Use the formula n factorial is equal to n times quantity n minus 1 times quantity n minus 2 times quantity n minus 3 and so on up to 2 times 1. There are 3 persons to be arranged, so n is equal to 3. 3 factorial is equal to 3 times 2 times 1. And 3 times 2 times 1 is equal to 6. Therefore, there are 6 different arrangements. Example 4. In how many ways can you answer a matching type test consisting of 10 items with 10 choices? We all know that in a matching type test, once you have selected a letter, it can no longer be used. Therefore, this situation also shows permutation just like in picture taking. That is, there are no repetitions in your answer. Since there are 10 choices, n is equal to 10. Applying the formula, we have 10 factorial equals 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Multiplying the numbers, we'll have 3,628,800. Imagine, if you haven't reviewed for your exam, it will be very difficult to perfect it since there are 3,628,800 ways to answer the test. Example number 5. Simplify the following expressions. Letter A, 8 factorial over 7 factorial. Letter B, 5 factorial over 2 factorial. Letter C, 7 factorial over 5 factorial. And letter D, 1 factorial over 0 factorial. Let us show our solutions. For letter A, given is 8 factorial over 7 factorial. First, expand the numerator and the denominator. Thus, we have 8 factorial over 7 factorial equals 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 7 times 6 times 5 times 4 times 3 times 2 times 1. Here, we do not need to multiply the numbers. Instead, we will cancel all common factors in the numerator and the denominator. We cancel 7, 6, 5, 4, 3, 2, and 1. The remaining number now is 8, and the correct answer is 8. Another shortcut that we can also use is this. 8 factorial over 7 factorial equals 8 times 7 factorial all over 7 factorial. Here, our denominator is 7 factorial. We can stop at 8 times 7 factorial in expanding our numerator. Thus, we can cancel right away 7 factorial in the numerator and the denominator. Easy, right? And still, our answer is 8. Now, let us try to answer letter B. Letter B, 5 factorial all over 2 factorial. In this case, we will expand the numerator until 2 factorial only. We now have 5 factorial over 2 factorial equals 5 times 4 times 3 times 2 factorial all over 2 factorial. We can now cancel 2 factorial in the numerator and the denominator. This will leave us 5 times 4 times 3. And 5 times 4 times 3 is equal to 60. Therefore, the right answer is 60. Let us now proceed to letter C. Letter C, 7 factorial over 5 factorial. In this situation, we will expand the numerator until 5 factorial only. We now have 7 factorial over 5 factorial equals 7 times 6 times 5 factorial all over 5 factorial. We can now cancel 5 factorial in the numerator and the denominator. This will leave us 7 times 6. And 7 times 6 equals 42. Therefore, the correct answer is 42. Before we proceed to letter D, an important property in factorials is this. 0 factorial is equal to 1. Let us apply this property in answering letter D. Letter D, 1 factorial all over 0 factorial. 1 factorial equals 1 and 0 factorial equals 1. Thus, we have 1 factorial over 0 factorial equals 1 over 1. And 1 divided by 1 is equal to 1. Thus, the correct answer is 1. I do expect that you have learned a lot from today's episode. Summing up the things we've learned, we can list down the possible outcomes of an event using tree diagram. Another way is through listing method. Next, a shortcut that we can use to find the possible outcomes is the fundamental principle of counting. A permutation is an arrangement of things in a definite order or the ordered arrangement of distinguishable objects without repetitions among the objects. In permutation, order or arrangement is really important. Permutation uses the formula n factorial equals n times quantity n minus 1 times quantity n minus 2 times quantity n minus 3 and so on times 2 times 1. In simplifying expressions involving factorials, we can use cancellation method. Let us now practice what we have learned today. For your assignment, try to answer the following exercises. A. Directions. Simplify the following expressions. Write your solution and answer on a sheet of paper. Letter B, directions. On a sheet of paper, write P if the situation involves permutation. Otherwise, write NP if it does not show permutation. Letter C, directions. Solve the following problems. Write your solution and answer on a sheet of paper. Thank you for sticking around and hope to see you soon on our next episode. Make sure to practice what you've learned today because learning does not stop here. Always try harder and exceed your limit. Go out of your comfort zone in challenging yourself in solving math problems because math is interesting and fun to do. If you want to watch my previous episodes or a replay of this episode, simply go to my official YouTube channel, Ron Alfie Yuson. Be sure to subscribe and hit the notification bell so that you will be notified each time we release a new video. Again, this is Sir Ron Alfie Yuson, your math teacher, signing off. Bye-bye!